I'm going to work out the rational exponent and radicals review that we had for homework. The first problem, it says find the indicated nth root. So what that is the number is 81. It says nth root of a, so the number is 81. And I want to find the nth root. So that would be the fourth root of 81. The answer would be 3. Moving on to the next one, it says find the nth root of a negative 32. So we're looking for the fifth root of a negative 32. Because it's an odd root, we can't find the nth root of a negative number. If this would be an even number out here for the index, we would have an imaginary number if we had a negative under the root sign. So this is going to be negative 2. The next one says simplify without using a calculator. So we have 16 to the 3/2 power. That would be 16. The root would be 2. Power would be 3. So the square root of 16, and normally don't show the 2, so I'm going to erase that. And so what we're going to have there would be the square root of 16. That would be equal to 4. Then the 4 would be cubed, so we'd have 64. Okay, the next one says write each expression in radical form. So what we have is a rational exponent. Let's change that to radical form. So the first thing I'm going to do is notice that it's a negative. So let's go ahead and get rid of the negative by moving it across the fraction line. So that would be 4n in parentheses to the 5/3. Now the whole 4n is going to have to take this exponent. So that would be the 3 is the root. So that would be a cube root. And the 4n would all be underneath the radical. And then we would take that to the 5th power. The next one is 7. And we're taking that to the cube root. Then after we cube root it, we'd square it. This is the power. That's the root. The next one, we're going to put it in exponential form. So what we have here is now the whole 2b is going to have to have this 5th root. Of course, the power on this is 1. So we're going to have to put 2b in parentheses. And then it'd be to the power of 1 in the 5th root. The next one says put it in exponential form and then evaluate using a calculator. So what this is going to be is it's a square root and then it's going to be to the 3rd power. So that would be 7 to the 3/2. And if we wanted to put that in a calculator, we would have to say 7, something like that. And then we would say 3 divided by 2 and we'd have to put the 3 divided by 2 in parentheses because the whole 3/2 is an exponent. So let me evaluate that. Okay, let's go ahead and move on. The next one is rational exponents. So what we're going to first do is multiply across in the numerator. So if I do that, I have, well, I'm going to say that would be 3. And then the r, it would be to the 4/3 plus 1/2 all over r to the 1/3. So let's add those two exponents together. We'll have to give them a common denominator. So that would be 3 r. 4/3 would be 8/6. And 1/2 would be 3/6. All over r to the 1/3. Okay, so I've got 3r to the 11/6. All over r to the 1/3. Okay, so the 11/6 is a bigger exponent than the 1/3, so it's going to be the top r to the 11/6 minus r to the 1/3. So that would be 3r, and now let's give them a common denominator at the same time. So that would be to the 11/6 minus 1/3, which would be 2/6. So that would be equal to 3r to the 9/6. which then we can simplify that exponent 3r to the 3/2. Let's move to the next one. We're going to distribute the 2 exponent in. So we're going to have x squared. So when the 2 multiplies by the exponent of 1 on that x, we get the squared. Then it's going to multiply by x to the 1/3, so we're going to get x to the 2/3. Now we're going to have to subtract the exponents. We'll take the largest exponent, which is the 2, minus the smaller one, which is the 2/3. So that would be x to the 2 minus 2/3. Let's give those a common denominator. It would be x to the 6/3 minus 2/3, the x to the 4/3. Let's move on to the next one. So the first step is going to be to multiply or add the exponents in the denominator, because I'm multiplying the 2 x's together, so the bases stay the same and the exponents add. That would be equal to x to the 1/5 all over x to the 2/5 plus 1/5. That would be 3/5. Now then, I'm going to subtract the largest exponent minus the smallest one. The largest exponent is the 3/5, so this would be a 1 all over x to the 3/5 minus 1/5. That would be x 1 all over x to the 2/5. Now what I have a rational exponent, a fractional exponent in the denominator, and I can't have that. So we're going to have to change that form. So what we need to do is we need to get this to be x to a whole number. So the next whole number for 2/5 would be 5 over 5. So I need to get the bottom to be x to the 5 over 5. And what I need to do is figure out what I need to multiply to do that. So what I'm going to multiply by since I have a 2/5, I'm going to multiply that by x to the 3/5. Of course, if I do that to the denominator, I have to do that to the numerator. So when I multiply, I'm going to end up with x to the 3/5 all over x to the 5/5, which 5/5 is 1, so I can rewrite that as x to the 3/5 all over x. And that's actually the proper form, even though it doesn't look to be the simplest. Let's move to the next one. So I'm going to distribute the exponent in, so I'm going to have a to the 4/3 times the negative 2/3. That would be a. 4 times 2, that would be a negative 8. 3 times 3 is 9. The denominator would be a, and now I have 3/2 times the negative 2/3. So 3 times 2 is 6. 2 times 3 is 6. So let's continue with that. Now, since I have negative exponents, I'm going to move the numerator down to the denominator. That would be a to the 8/9. And the denominator would move to the top. And of course, negative 6 over 6, that's going to become positive, and 6 over 6 is 1. So I'll have a all over a to the 8/9, and a to the 1st is a larger exponent than 8/9, so I'm going to take the top one and subtract the bottom one. Giving those a common denominator, we would have a to the 9/9 minus 8/9, a to the 1/9. Next one is to simplify radicals. And so what I need to do is do a factor tree on 405 to see what perfect powers I can pull out of that. So let's go ahead and do that here, 405, and let's do a factor tree. So 5, and I would have 81. Then 81, I'd have 3, and that'd be 27. That'd be 3 and 9 and 3 and 3. So what I'm looking for is perfect fourth powers, and you can see that we actually have 4 3s. So let's go ahead and rewrite this. This is going to be 3 times the 4th root, and what we found is we've got 3 to the 4th times 5. And What's going to happen is this 3 to the 4th will come out as a 3 and multiply by the 3 in the front. So I will have 9, and the 5 will be left underneath there, so I have 9 times the 4th root of 5. Okay, let's move to the next one. Okay, for the next one, we're going to multiply the number parts together, and then what's under the radicals together. Now we could try to simplify this first, or break it up into its factors so that it'd be easier to factor later, but let's just do it as one big, let's go ahead and multiply the 25 by 100. So if I take 5 times a negative 6, I'm going to get a negative 30. And under the root sign, I'll have 25 times 100, which would be 2,500. So we're going to need to do a factor tree on 2,500 to see what that is, see what factors it has. So let's go ahead and do that. I'm going to erase this 1. So I have 2,500. Let's take out a 5. That would give me 500. Let's take out another 5. That leaves me with 100. Let's take out a 5. That leaves me with 20. Let's take out a 5. That leaves me with 4. That's 2 times 2. So I'm looking for 4th roots. So what I have is I have these 4 5s. So I can rewrite this as a negative 30. And that would be 5 to the 4th times what I have left is 2 times 2. The 5 to the 4th will come out as a 5. And that 5 will multiply by that negative 30. So that would be a negative 150. And what I would have left underneath there is the 4th root of 4. Okay, the next problem. What we're going to do is if the radicals are the same, then we can just subtract or add the coefficients, just like if I was dealing with something like a negative 2x minus 2x. So I'm going to have a negative 4 times the 4th root of 48. Now I can't leave it at that because I need to see if the 48 can be simplified. So let's do a factor tree on 48. It'd be 2 times 24, 2 times 12, 2 times 6, 2 times 3. So we can see that we do have 4 2's and it's a 4th root. So I'm going to rewrite that as a negative 4 times the 4th root of 2 to the 4th. And what I would have left is this 3 here. So the 2 to the 4th would come out as a 2 and multiply by the 4. That'd be a negative 8. And I would have the 4th root of 3 left. Okay, the next one, we need to have the same radicals. So you can see that I do not. So hopefully I can change the 4th root of 64 into the 4th root of 4. So to do that, I'm going to have to simplify the 4th root of 64. So let's do a factor tree on 64. And that's going to be 2, 32, 2, 16, 2, 8, 2, 4, and then 2, 2. So I have, it's a 4th root, or 4th root, so I can have these 4 2's will come out. So let's rewrite this term in the front. So I have 2 times the 4th root, and what we have actually is 2 to the 4th, 2's left over, times 4, plus 2 to the 4th root of 4. This 2 to the 4th will come out as a 2 and multiply by this 2 in front, so I have 4 times the 4th root of 4, plus 2 times the 4th root of 4. And you can see now that the radicals are the same, so the coefficients will add 6 times the 4th root of 4. Okay, let's work on the next one. And what we have here is, let's hold this one for later because you can see that we have a 2 plus the square root of 3. So we have to rationalize this denominator because we have a radical in the denominator, but it also has something added to it. So it's going to be worked differently than these other 3's. Problems. So let's take a look at these other 3. Before I start doing any rationalization of the denominator, I'm going to look to see if anything is going to be easy to solve. And when I look at it, let's take a look at this first. We have the fourth root of 81. Well, 3 to the fourth power is equal to 81. So this part is going to be 3 right off the bat. So this one's going to be an easy one to solve. So like I said, before we start doing anything, let's see if we have some easy ones to solve before we start rationalizing. In this case, I would have the fourth root of 8, and we already said the fourth root of 81 is 3, so that's what I would have, and we would take a look at the numerator to see, can I simplify the fourth root of 8? And of course I cannot, so that would be my answer. Okay, let's see if we have another easy one to solve. And what happens here is, let's take a look here. If I can divide the denominator into the numerator, the denominator goes away and does not need to be rationalized, even though 4 is not a perfect cube root. And both would have to be perfect cube roots or be cube roots. So this is a cube root, this is a cube root, so they can combine under one root sign. And it would be 12 over 4. And now that I combine them, 12 divided by 4 is 3, so I have the cube root of 3. And that's as simple as it goes. So you can see that by taking my time and making sure that maybe I can simplify it by dividing the denominator into the numerator, that saved me a lot of time. Let's go ahead and move to the next one. And the fourth root of 25. That's not a perfect fourth root, so that won't help me. 25 does not divide into 5. That won't help me. So I'm going to have to rationalize this denominator. So let's go ahead and figure out what 25 is. Actually, that's 5 times 5. So let's go ahead and write it like that. And what you can see is that we want to get this to be, actually, we want to get that to be 5 to the fourth power underneath a fourth root. Because if I have a 5 to the fourth power underneath the fourth root, well, then that's going to be 5. So that's what I need. So why do I have to multiply to get there? Well, whatever I multiply by has to be under a fourth root, or that's not going to be able to combine with this 5 squared that's in the denominator. So 5 squared going to 5 to the fourth, hey, I need to multiply by another 5 to 5 squared. So that'll be the fourth root of 5 squared. If I do that to the denominator, I have to do the same thing to the numerator. Okay, so let's see what we have. We have a 5 to the first times 5 squared. Those will combine in the numerator. So I have the fourth root of 5 cubed. So we can see nothing's going to come out of the numerator when I simplify it. Anyway, the denominator is simply going to be 5. And the numerator will be the fourth root of 5 cubed. Let's move over to number 19. And what we're going to have to do to get rid of the square root of 3 that's in the denominator is we're going to have to multiply the denominator by its conjugate. And when we do that, it's the sign on the radical that's going to change. Not the sign on the number, but the sign on the radical. So what I would do is I would multiply both the numerator and the denominator by the conjugate of the denominator. So let's multiply 2 times 2 minus the square root of 3. And the denominator, 2 minus the square root of 3. So notice that I've left the sign on the number part the same, but I've changed the sign on the radical. So we'll use our multiplication methods. 2 times 2 is 4. 2 times a minus square root of 3 is minus 2 times the square root of 3. My denominator will be found by using the FOIL method. 2 times 2 is 4. 2 times a negative square root of 3. Now let's take this square root of 3 times 2. And lastly, we have a minus and a plus, so this last part will always be minus. And we have a square root of 3 times the square root of 3, be square root of 9. Let's simplify. 4 minus 2 times the square root of 3 over 4. The middle parts drop out. 4 minus the square root of 9, so that's 4 minus 3. So I'm going to be 4 minus 2 times the square root of 3 all over 1. So it's 4 minus 2 times the square root of 3. Okay, the next one is the same kind of problem. However, it's just a little bit more challenging because we have a number multiplied by the square root of 2. Same basic technique though, so let's multiply the top and the bottom by the conjugate of the denominator, and that would be 5 plus 4 times the square root of 2. The bottom would be times 5 plus 4 times the square root of 2. So let's see what we get. 4 times 5, that's 20. 4 times the square root of 2 be plus 16 times the square root of 2. The denominator will be 5 times 5. 5 times plus 4 times the square root of 2. Negative 4 times the square root of 2 times 5. And lastly, we'll have we'll have a minus and a plus, so that's going to be a minus. The 4 times the 4 is 16. And the square root of 2 times the square root of 2 would be the square root of 4. So let's simplify that. We'll have 20 plus 16 times the square root of 2 all over 25. The middle part drops out, and I will end up with the part coming out of the radical will be a 2, which will multiply by 16, so that'll be minus 32. 20 plus 16 times the square root of 2 over negative 7. And this negative 7, we can see that it would not divide into any other thing in my numerator, so that'll be my final answer. We're on to the last problems. Okay, so what we have here is we have a number and some variables with exponents. So let's go ahead and break these up into their exponents to see what's going to come out. So so let's take 324, and I'm going to divide by 2, do a factor tree. It'll be 81. So we can see that what we have is we have 4 times the fourth root. We have 1, 2, 3, 4, so I have 3 to the fourth times 2 squared. Now I'm going to break this x to the seventh up into perfect fourth powers. So that would be x to the fourth times x cubed, right? Because 4 times 3 would add to give me 7. Let's take y to the fourth, and we'll just leave it as y to the fourth because that would be a perfect power of the fourth root. Z to the seventh, let's break that up in z to the fourth times z cubed. Now the things that are going to come out are going to be anything that is a fourth power. So this 3 to the fourth would come out as a 3. This x to the fourth would come out as an x. Y to the fourth would come out as a y. Z to the fourth would come out as a z. Anything that is below a fourth power will stay under the root. So the 2 squared will stay under, the x cubed will stay under, and the z cubed will stay under. So let's go ahead and write what I have. So I have the 4 would multiply by the 3. Now I'd have the fourth root, and I have 2 squared left under, that's 4. I have this x cubed left under, and I have the z cubed left under. And I forgot to put my letters that came out, so I had an x that came out, and I had a y, and I had this z that came out. They would all multiply together. That'd be my final answer. Okay, this last one is a bit challenging, so let's go ahead and see what we have. Let's simplify inside the radical first, so that would be the cube root. And I have 27, that's not going anywhere. But I have x to the 6th over x cubed. Well, that's x cubed in the numerator position. I have a y cubed and a y to the 6th. That would be 6 minus 3. So I would have y cubed in the denominator position. And then I have z squared as a numerator. Okay, so let's go ahead and maybe break these up into separate cube roots. So I would have the cube root of 27x cubed z squared over the cube root of y cubed. So in the numerator, 27 is 3 cubed. So a 3 would come out. The x cubed comes out as an x because it's a cube root of a cube. The z squared would stay under. And in the denominator, I have the cube root of y cubed, so that comes out as a y. And that would be my answer.